Oh.
All right, looks like we got about three of them online so far. Folks, we'll get the meeting started here in just a little bit. Let's see. C. Larson, you wanted to present too, correct? Oh,
No,
go ahead,
not
you're
I.
on mute. Say again?
No.
No?
No, not
Oh.
I.
Not I, he said.
Not you, okay. And maybe I'm mixing up the email. We'll figure it out who we got here in a minute. Okay. Okay, so let's see. You know there's pizza, right?
I do know, yeah. I'm back.
Double checking. Okay. Give people another couple minutes here to come in and make sure they've got pizza and whatever else they would like to do. Just a quick note, and I'll mention this again. The pizza is kind of a one-off tonight. So that was provided by Microsoft Reactor Room. They may do it occasionally, but there's no guarantees. So kind of depends on budget and such.
So I think Brad was saying that there was some special code that you could do to ask them to do it, and that that's what he had done.
Oh, no, he was joking.
Oh.
Yeah, actually.
Pizza code. And where do you send it?
So you find Anna.
More often, and then we will just clue onto or just copy into when he asks.
Yeah, no, Anna actually talked to me about that a couple of months back. And the magic code is find Anna and beg. The other code is provide funding.
First one's easier.
Yep. Having done both, no.
I'm sorry, I forgot your name, but I know you used to be.
Yes.
Have you got any position?
Nope, still looking. Job market is very difficult right now.
Oh, yeah. Amazon, I heard, is insisting that people go back to offices.
Yeah.
And many people say that's just a way of getting people to leave voluntarily.
Could be.
So that.
It has worked in the past, apparently. Okay, we'll go ahead and get the meeting going here. I think we've got at least general mass for the moment. Okay, so folks, welcome to the Northwest C++ Users Group. First off, I'd like to thank all of our sponsors, primarily Microsoft. So tonight they provided us with the Reactor Room, the team support, and pizza. As I was mentioning, this will not be a regular thing, so don't like skip dinner thinking there's going to be pizza here. Or if I know ahead of time, I'll try to let people know. But I think in general, we probably won't.
But if you do skip dinner, I have an answer for you. Coming soon.
That's true. Okay, note we are on Microsoft's campus, so we're going to follow Microsoft Code of Conduct. Basically, be respectful of others, be friendly and patient. Be open to the questions. Basically just be reasonable. Announcements. I am looking for presenters for 2025. So I've got one tentative lined up so far. If anybody would like to present, and this would be a full presentation, please reach out to me. And yeah, I'm basically, I'll start pinging people and so forth. And kind of the season for that. Also, we will not have a meeting in December. So typically the December meeting lands very close to the holidays and people are busy doing other things. So yeah, we've traditionally skipping December. If you skip dinner and there's no pizza, Their Northwest C++ Coffee Club is now forming. So like many of the other groups here, there's kind of the after party. And for Northwest C++ users group, it's the bar at the local Red Robin.
And there's no coffee involved.
Well, there isn't.
It's just-
You can get coffee if you
We
want.
actually asked, and they do have coffee available at that
just
time.
Okay, fine.
But the reason it's called the coffee house is because back in the 30s and 40s, atomic physicists would gather in coffee houses to discuss their craft. And a lot of the atomic physics that required for building, for instance, atomic weapons came about because of those coffee house meetings. So the idea is the same thing, that a bunch of us can get together, can talk about our craft, can share knowledge, and we'll talk about other stuff too, I'm sure.
And those coffee houses too, I'm betting had plenty of alcohol. Nobody could have come up
Oh,
with
yes.
those ideas without.
And actually having watched
My
Oppenheimer,
opinion.
watched Oppenheimer last weekend, I don't remember seeing that scene in there, but I'm sure it was there somewhere. Okay, so tonight, so what we're going to do tonight is a little different. We're going to do lightning talks. So these are short presentations. As with any other feature presentation, please keep your questions short and focused so everyone gets time. I'm suspecting we're going to have plenty of time tonight. So, if we don't have, I know I think you've got yours, right? Okay, and I've got it on here. So we've got at least one presenter. Does anybody else want to present? I had someone reach out to me on email. And it was just kind of a initials type email, so I'm not quite sure who the person really was. So do we have anybody else local or online? Hello. Hello. Were you going to present tonight? Or? Nope. Okay, well, we've got one to start with. And following that, we may just have an open discussion. So with that, we want to just keep it simple here. Save. I'll just bring your slides up.
Cool.
So our first speaker tonight is Peter Williamson. And
Perfect.
yep. Where's the little camera thingy? I don't care if I'm on camera, but somebody else should be. Let's see. Get the camera going here a little better. Okay, take it away and feel free to take all the time you'd like.
All right.
We got plenty.
I will just say next whenever I'm ready for the next slide.
Yep, sounds good.
So coding with AI help. One of the things that I've been wanting to understand for a few months now is how much help actually is AI when coding. So we were told maybe 6 months, 8 months ago, yeah, ChatGPT can help you code. Hey, look at this. Here's GitHub Copilot. It can help you code. But how do you set it up and how much help is it really? Is it really all that useful? So that's a question I wanted to answer. Next. So as an overview, there are several things you can do. The first one is to hook up GitHub Copilot. What that will do is it'll watch as you type, kind of as like a very fancy autocomplete. So it will, when it sees you start typing a function, it will try to guess what you're doing. And it can use the whole rest of the file as context. So it might be able to, and sometimes actually does, guess exactly what I want and put in exactly what I want. Although most of the time it just finishes the comment and about half the time it gets what I was going to say, and about half the time it doesn't. So you can hook up Copilot, or there's an open source free version of something called Codium that they say on their website is going to be free and stay free. You can hook up to your editor. So I hooked it up to VS Code, I hooked it up to Xcode, I hooked it up to Emacs. I didn't actually try hooking it up to Vim, but I know that those three works. At least Copilot works. Open source Codium did not work with the Emacs bindings. So they've got a page that says, here's how to hook it up with Emacs. I followed all their instructions, didn't work, debugged it, couldn't get it to work, gave up. So as I said, this will provide completions as you type. Second, you can hook up ChatGPT or Gemini or Claude or Llama or whichever other major engine of choice to your editor directly. And once again, I hooked it up to X or to VS Code, to Xcode, to Emacs. I didn't actually hook it up to Vim, but it should be totally possible to hook up to Vim and other editors too. And this will give you a way to make requests. So GitHub Copilot, you don't actually say, hey, go write me a function to do X. But if you hook up ChatGPT or Gemini or Claude or Llama, you can say, hey, in the context of this file, write me a function to add this feature, and it will do it. How well does it do it? We'll talk about that as we go along. Next. So stories, Copilot, Square, and Square Root. So this is a Copilot story. Next. So I start typing the part in bold, and then everything else is what I get for the completion. So in the .h file, I type int space square, open curly bracket, and it says int space x close paren semicolon. Okay, seems pretty obvious. In the CPP file, I type int square, and I don't even know if we even got all the way to the end of the word square before it completed the function and did it right. Return x times x. Okay, looks good. Let's take this next further. Next. So then I go into a Google test file and I start typing the top part, test underscore F for framework, CMake hello test, SQU, and then it writes everything else, which is actually pretty good. It is correct. And the test passes. Okay, I am pretty impressed at this point. So I keep going. Next. Now let's do square root. So I mistyped and said int square underscore root. I probably should have used a double, which may be what led to it doing a bad thing. And then when I typed int underscore root, it returned x times x. There's something a little bit off about what they did. Next. And then I go, without even noticing that it's done the wrong thing because it did the right thing before, I go in and type the test, and the test is absolutely correct. I run the test and it fails.
The function name is the second thing argument, the function name.
So the first argument is the expected value. The second argument is the actual value.
Test that.
Okay, the first argument is the test file or the test class.
No, I asked because in your previous slide, you had square underscore root all in lowercase. That's different.
Yeah, so that is not at all corresponding to it. So this is just the name you want to give this particular test.
Oh.
So I just named this test square root instead of square underscore.
Oh, okay. I didn't notice the square underscore.
When we actually call, we use the square underscore root. So I went back to the previous slide and realized, oh, the definition of square root was not quite what I was hoping for. Next, and then next again. So other things about copilots is sometimes it reads the to-do in file and actually does the to-do. I was impressed with this. Many times it just offers to finish my comment, not that useful. About half the time it gets what I was thinking, about half the time it goes in a different direction. Sometimes it gets things exactly right. And it turns out more often than not, it'll get them exactly right. Sometimes it hallucinates badly, as we saw. Again, part of that may be my fault for not using a double, but maybe not. Yes.
So in the previous slide, why do you think it got the test correct? My hypothesis is because you use the name square root for one word. In the same slide, it says the bottom bar is typing square O, and then it generated the rest of it, and all of it was correct. So it kind of used that name, I'm guessing. What do you think?
It's really hard to say why an AI says what it does.
Yeah.
There aren't
How about
debugging. We can't set breakpoints.
Function code.
We can't put
And get the
debug
test.
probes into it. We have to do whatever is required, and it's going to just spit out something. We can guess, but guessing is all we can do.
Did you try naming the code? Did you try removing the underscore and just naming it square root?
Nope, didn't try that.
You didn't try.
I'm just showing you what I tried.
Yep.
So I've also written an app for the Apple Watch using AI code, using both GitHub Copilot and ChatGPT 4.0. And this is written in Swift, not in C++, so I feel a little bit sheepish talking about it. But I don't know
their language.
and I do know C++. So I took advantage of the fact that the large language model actually knew Swift better than I did. And when I made that class, it gave me exactly what I was looking for. Are we back up one slide?
Sorry.
And let's see, it gave me exactly what I was thinking about. Okay, so maybe use the to-do comment I had in another file to figure out what it is I was asking it to do. All right, let's go to the next slide. So the story is about GPT. So with GPT, I can ask for, please add this feature to the code of the file that I'm already editing. It loses the comments in my suggestions. So when I say, please add code to do this, it will show me, here's the whole file I'll look after I've done this. And it gets rid of all my comments. So I can't just cut and paste the file into place. I have to sort of like manually do a diff, say, okay, here's a new function, cut and paste a new function in. Here's the call to new function, cut and paste that in, and then life is good. It is very helpful for research. So when I'm programming for the Apple Watch, which I didn't already know how to program for, and I'm learning how to do things in Swift, which I didn't already know, it knew how to program for the Apple Watch and it knew how to program in Swift. So the amount of research time it saved me was immeasurable. Each one of these things is like, okay, am I going to read the whole Swift book to know how to do this? Am I going to spend 30 minutes trying to craft the exact right query and to get the answer that I need for how to do such a thing in Swift, or how to use this API properly in Swift UI? ChatGPT had my back and answered those things right away. So it was a huge time saver. It can hallucinate here too. So one time I had said, what I want to do is I want to put my phone into focus mode. And in focus mode, it will block notifications. So I asked it to programmatically put the code into focus mode. It turns out there is no such API to do that, but ChatGPT didn't know that, and it came up with something anyway, and it ended up giving me something that was a deprecated API that Apple doesn't even support anymore, which didn't do the job in the first place. How do I do X? So if you want to figure out how to do X, then using ChatGPT instead of Copilot may give you a good answer. There's one time that it wrote some code that had a bug. So I said, hey, there's a bug in this code. How do I fix it? And it gave me the right answer. Sometimes I've had to do that 2 or 3 times in a row because it gives me something else with a bug and something else with a bug. Sometimes it'll give me 2 or 3 things with a bug where there's a flaw in the general approach. I have to look online, figure out what the flaw is, then I come back and say, hey, there's a flaw in the general approach. We should have done this instead. And then it might give me something that works. Yes.
Did you notice whether, I mean, it's a bit different using the tool if you're like just learning a new language and you really kind of sort of don't know the sharp points and boundaries, but I'm just wondering if the sort of, the obvious like square root complete failures were those kind of things reduced in Swift compared to C++? I mean, did you notice it wasn't giving you these like?
I didn't have any hallucinations like that in Swift.
Okay, that's interesting.
But as I said, I didn't let Copilot do much of the work in Swift. Every now and then it completed the exact function I want, but more often than not, it just tried to complete the comment or complete the line I was typing on.
Interesting.
Okay, next slide, please. Local LLMs. So actually the title of this is wrong now because I got more information last week. So I tried using llama.cpp and Llama file. So Llama is Meta's large language model, and Llama 2 has 3 versions, a 7 gigabyte version, a 14 gigabyte version, and a 70 gigabyte version. And the 7 gigabyte version will run in memory in most people's machines. I wanted to run the 70 gigabyte version. And I have 64 gigabytes of RAM, so that's actually reasonable that it might fit. And I have a really nice GPU. I have like a 4080 NVIDIA that it can use. So I was thinking, hey, maybe this will work. Let's see if it actually gives me reasonable results. And what I found is when I was running with Llama 2, the 70 gigabyte model or 70 billion parameter model did actually run, and it produced valid C++ code. Okay, yay. Maybe not great C++ code, but it was valid code, and it basically did the simple things I asked it to do. It was slower than I could have typed it myself, so it was really slow. And ChatGPT 4.0 is pretty fast. ChatGPT 4.0, like 10 seconds, I'll get a whole page worth of code. Maybe not even 10 seconds, maybe only 5.
But that was local?
No, ChatGPT 4.0 is not local.
With cloud, right?
Right, that's with the cloud.
Yeah, okay.
The Lambda model is local and is slower than I could type it, if I knew what I was typing. It didn't have to go look things up, but I do.
What GPU do you?
It's like last year's second down from the top of the line Intel.
Intel?
Yeah, so it's an Intel.
Okay.
It's like an i7. It's whatever the i7 was current last year. I didn't buy the topmost one, but I bought like one down from the top.
Yes, for GPU.
The GPU, I'm sorry. It's a 4080, so it's an NVIDIA 4080.
RTX?
Yes, RTX. So it was also one down from the top of the line, which is 4090. Okay. New thing that happened last week is I tested Llama 3. As it turns out, Llama 3, the models are much faster. It's not quite as fast as the network, but it's a whole lot faster than I can type. It's fast enough to be useful in a single person programming scenario instead of go get a cup of coffee while I wait for it to solve this big problem.
Yeah.
And the code seems to be a lot better, maybe on par with ChatGPT 3.5. So it's not up to the latest, but it's interesting that you can get really good code locally. Now, why do we care? Well, let's say you're working for a company who doesn't want you using large language models because it might expose your source code to the network. Let's say you're working on something proprietary and you don't want it exposed to the network. You don't want this new startup code that you're having to suddenly be easily clonable by somebody else who just asks the large language model and it just clones your code. The same reason you might use a private repository in GitHub as opposed to a public repository for your code. So given that it can be as fast and as good, or as just almost as good as the large language models online, I'm starting to think, in the future, people might start just building this into your editor. Wouldn't it be cool if it was just built in, if we didn't have to contract to a service, if all we had was it taking up some extra room and taking up some CPU code while you were typing? Next slide. So conclusions, I think using AI to help you code really is the wave of the future. Productivity will improve. I've heard claims that productivity is 2x better. I haven't found that to be the case myself. It seems like less than 2x, but it's saving me a lot of research time. It's hard to estimate how much time I would have spent researching. AIs do still hallucinate. Don't trust what it gives you. Pretend you have a junior coder on your team and you need to code review everything they come up with. Let's see. As I mentioned, it might be able to using a deprecated API. Still not great for proprietary code bases, but as I mentioned, local large language models might be able to help quite a bit. It can save a lot of time typing in Copilot, but even more importantly, it can save time in research when you're working in a new area. When Copilot is magical when it happens and it gets the right thing. So sometimes I'll be typing like the start of a function, and I'll just see the whole function pop up. I just press accept. And there's the function, and it compiles, and it works, and life is great. Let's see. And lastly, this is where I was mentioning I was going to get back to you, Lloyd. Let me know if you'd like a longer talk with more how-to in it. So I can tell you, this is how I hooked up Emacs. This is how you hook up VS Code. This is how you hook up to Xcode, even though Xcode doesn't have a GitHub Copilot module in it. Right.
Yes, please, because that's exactly the question I was going to ask you.
Okay.
Almost word for word.
Yeah,
Okay,
okay, so I will plan a talk for next year on that, and maybe I'll go ask Brad if he needs a talk on that.
and which month would you like?
Maybe January, so I have a forcing function.
You
So
got
I'm planning to do another talk later next year, my C++, remedial C++ talk.
Yep.
It'll finally be 5 years from C++ 20, but I'm only a third of the way into the book. So I've got a lot of reading to do before I can make that other talk.
That was in my notes. You got 2 for next year. I'll take it.
Yeah, put that one late so I have time to read it.
No problem.
You had a question?
Yeah. I know this examples, maybe just for presentation, are pretty simple. I mean, square. But how many functions are you using to base this conclusion slide on? And what kind of functions are they? Do they involve like complicated logic, mathematical stuff? Okay, the Swift function, logic, and calling some API. What sort of function? How many and what?
So basically, I've been using it for developing my whole Apple Watch application.
Oh,
So from start to finish, I had the LLMs turned on and helping me out.
so that's your new job. You're writing an watch app.
That is not my new job.
Okay.
That is something I'm doing on the side to learn how to write apps. Yeah, you could think of it as a new job since I don't have any real job that's paying me.
If you just need
No, it's just a training exercise.
from my laptop to yours.
How many
Okay.
functions?
We'll get you as soon as this one's done.
How many functions?
Have you tried this to base these conclusions?
Uh,
Like tens, hundreds,
right.
thousands?
I've got between 2,000 and 10,000 lines of code, I would estimate.
Okay.
So it's not a huge amount of code, but it's helped me solve some very gnarly problems in a language and an OS that I was unfamiliar with.
No function count? You don't have?
No, lots of function calls.
No, function count, number of functions.
I don't have any counted number of functions in my head, maybe 50.
Let me ask you something regarding both languages. What was the quality of the code? I mean, like use of counts, this kind of good practices that we always do in C++. What was your experience with that?
So for the Swift code, the quality was always good. So it was well formatted. It was easy to read. It had well-named variables. It had no obvious bugs. It generally compiled first time and generally ran first time.
Nice.
There were bugs, don't get me wrong. I did discover them. More often than not, the bugs were it didn't do what I wanted it to, not it did something wrong.
And C++?
C++ is pretty much the same. So I did a lot of my testing was done in Swift, not C++. But the C++ code that I wrote, except for the square root function, it did pretty well. So I've been studying for programming interviews for my next job. What I will do is several times a week, I will do one of the coding problems from LeetCode. So first I will do the whole coding problem myself, and then I will ask the LLM, hey, how would you solve this problem? Now, generally, I don't use the local one for that. I use ChatGPT 4.0, which is like one of the best models available out there. And these solutions are always correct, pass the test, readable. They're not always understandable. So sometimes it uses an fact-based approach for something without really explaining how it works, no comments whatsoever. So it solves the problem, but I wouldn't call it maintainable code because it's difficult to understand.
I see.
Whereas my solution was much easier to understand, although possibly not quite as performant as the one that they built.
Okay.
So I generally prefer my solutions for writing maintainable code, but their solutions might be faster.
I see. Thank you.
Yes.
I have a question. So you mentioned that one reason companies might not allow such a usage for their employees' code is that their code might not be proprietary. It might be out.
Right. So anything you send to a large language model will end up being used as training data. And you signed away that right somewhere when you signed the agreement to use it.
That's part of the agreement with.
Yep.
So there's only for open source code then.
It was trained on open source code.
It was trained on, but if you use it to write any code, that becomes open source too. Or it's not open source, but it goes back to the.
As long as you don't mind somebody else looking at all the code you wrote, you're cool. Go ahead and use the online one. If you do mind, then you probably want a different kind of solution. There are several solutions available. One of them is using a local LLM that doesn't send any model out. But there are certain types of GitHub Copilot accounts you can buy where everything goes into a private database and they pinky swear promise that nobody's going to be looking at your code.
No, I didn't know all these details, but one other scenario which occurred to me was security conscious code. I mean, something which is extremely critical and should not have security bugs in it. I would probably think a human being writing such code would be better off. What do you think?
For right now, I would prefer to have a human writing such code to make sure that all the proper factors are considered.
Yes.
That may not forever be
That's
true. So humans have a certain error rate. At some point, the error rate of the LLMs might be below the error rate of the human. At that point, maybe you want to have the LLM writing the code, not the human.
Yeah. That's one scenario that can you think of any others where a company might not want to use this feature, this thing, technology?
Well, yes, I can think of several. So let's say you just hired a bunch of junior programmers fresh out of college. Let's say they got through college by using large language models to write their code. Do you really want them using large language models to do all their code writing once they get into the industry? Maybe, maybe not. It depends on their judgment and how carefully they prune what they get back. And that's something we'll figure out over time. So I have been talking to a lot of my colleagues in different companies, and some of them, they don't want to use LLMs for different reasons. So some of them, they don't want to use LLM because they don't want the devs to be lazy. They want the devs to think hard. Some of them don't use LLMs because their code might become unproprietary. Some of them do want them to use LLMs so they'll be more productive. I think that's going to continue to change over time.
So that's actually an interesting point, right? So in the Renaissance, there were master painters that would have a whole bunch of apprentices, and the guy with the vision would say, you mix me the colors, you prepare the canvas, you paint me a background. And then the master was so much more productive because he had this army of apprentices. And the apprentices would spend many years mixing paints, preparing the canvas to learn the basics, and then they would go on to become the masters. So I wonder what happens when we lose, because all of us that have decades of experience, we know what we want from these models, and we say, do this, then I'll come and fix. Once you don't have that expertise because you never went through that hard training, what happens? Hopefully the models will be so much better by then, but it's a question I ponder.
Yep. So long ago in college, I took a class where I learned assembly language. I have not used assembly language since then. So I just sort of trust what the compiler does, and maybe it does a good thing, maybe it does a bad thing. I think it will sort of be like that. We'll still have smart people. They'll still have to understand at some level what's going on. But quite possibly more and more of the work they're trying to do will be automated.
Hopefully they'll get that good, because the compiler is deterministic.
Yeah, that doesn't sound like a correct analogy, assembly and high-level language. Even in high-level languages, you can write very bad code.
This is true.
You have to learn software engineering. It's something that has to be learned.
Oh, you're right. Software engineering has to be learned. It has to be understood. But you don't necessarily have to have gotten there by doing 20 years of programming. You have to understand the theory well. You have to understand.
His hypothesis was what will happen if you don't have that experience.
Right.
You will
And
just forget how to write code.
I don't think you will forget how to write code. I think writing code will still be an important part of what your skill set is and what you do. You may be letting the machine write it for you, but you're still going to have to be understanding what the machine does. And I think you could use the same gray cells to understand what the machine does as you might have used to write it. Now, could I be wrong? Absolutely.
Actually, I'm going to jump in on that one for a second, because I've actually seen that pattern in practice. So I'm going to pick on the Java folks for a little bit and the Python folks. But one of the things that I've seen in industry is that's different from the C++ and the C world, right, in particular. So in C++ and C, to do this effectively, you have to understand the memory layout, what's happening with memory, how memory is allocated, and so forth. What you find with developers that come out of college only having Java, Python, C#, the higher level languages, they make a completely different class of mistakes.
Yes. Yeah.
And the root of all of those mistakes is they don't know what's going on under the covers. And I suspect we'll see the same type of thing here.
I mean, it's like another anecdote, like at work, I end up supervising a lot of junior developers, and they're all like, 22, 23.
I know the feeling.
And they, it's the incentives are to like write code as fast as you can to get your feature done, to like get the promotion package together. And I can just see this exact thing where they understand the concepts. A lot of people understand the concepts from other languages that you don't have to think about this stuff so hard. And it translates into C++ sort of, except they have these just giant foot guns laying around the code. And I'm,
Yep.
I don't know.
I'll go one more level with that, because it's actually one of the things I've been seeing.
What is the word?
Foot guns.
Foot guns, yeah.
Just waiting around, like a copy assignment operator that doesn't like clear out the destination object properly, or just things like that.
Yeah. The other one I see is, and I've been seeing it more and more lately. I tend to work on systems now that are more composites of other things, right? Architecture becomes extremely important.
Interface design.
And yeah, and so I'm, when I code, I'm pretty strong on architecture. What I see is younger and less experienced developers coming in that have not worked on systems like that. And they do what I call bolt-ons, right? I needed to do X. Well, I'm just going to stick this here right? I need it to do Y. I stick that here. And pretty soon they've corrupted the entire architecture and it's not maintainable.
Yep.
So, yeah, I think with the AI, it's just like a developer, right? It's going to walk up different levels of this thing, and sooner or later it'll get to the top. But, I think our thing is, stay ahead of it for as long as you can if you want to stay relevant and use it as a tool, right? I mean, that's the strategy I've taken with it. Use it as a tool, be more productive, just like we did with assembly, right? I'd still like to go write assembly sometime because I enjoyed it, but it's generally not productive. So, you use a higher level language. Let's see, you did want to talk, right?
I have a very quick one, maybe 5-10 minutes.
Okay, so let's go on, if folks want to keep on this one for say until 7:20-ish or so, and then we'll switch.
I use them. I use the ChatGPT when learning or doing projects in languages that I'm not familiar with.
Yeah.
So I did a project earlier this year. I wanted to do a website to put some family genealogy stuff, private project, and I had no idea how to do Vue, which is kind of a lightweight React, right, or JavaScript. So I use ChatGPT extensively. And the learning, it helped me learn. It didn't always, especially if you have things where there is Vue 2 and there's Vue 3 and it got confused, which is which. Things that are more stable, like Python, where it seems to have a lot of training that it went through, produces very good Python code. Things that are in motion, like Rust, it will generate. My experience was that it outputs code where it gets confused, like me, about the borrowing, and it produces code that doesn't compile. But it's okay because it gives me an idea. I'll take it from there, and I would have not thought about something.
Yeah, that's been my general experience, multi-language as well.
Yeah, and then it loses the context window pretty quick. I can only go maybe like 4 or 5 iterations, and I say, you made a mistake here, you made a mistake there, and then it says, yes, thank you for pointing that out, and it makes the same mistake.
Yeah.
So I cannot trust it to do production code.
I had a bit the same of that problem in Swift. So there was one function I asked it to write for me, and it gave me an error. So I told it exactly what error it was and what line it was on, and fix it. And to fix it, it gave me the code that I already had, which was the same code it had given me before.
Yep.
That's when I had to learn more about what was really causing the error by doing some searching and some reading articles. And then when it came back and said, oh, the code doesn't handle this. Oh, okay. And then it got it.
Yep. Yeah. And, folks, I just noticed we do have a person with a hand up online. My apologies if that's been there a while. I just looked at the screen that showed it.
So I was wondering, like, this other strategy, instead of like giving a prompt, having an answer, and then making a suggestion, like, oh, fix this, like you said, might get caught in a loop where it can't progress. So what about just changing the original prompt to make a better prompt, right? Where you say, well, it's the same prompt, but you should have done this, and start over from the beginning all the time, so
you can totally do this. It has a long history context window. So until you exceed that window, it can remember the whole conversation, everything you said, but you can always start over from the beginning. One thing I didn't really cover.
You might actually get better results, right? If you, focus more, right? I should have had this better prompt to start with, right? Instead of, I don't know.
I tried both approaches and both of them seemed to work just fine.
Okay.
So I generally went for the approach of just saying, you made an error on line X, please fix it, because it was less typing on my part.
Yeah, I tend to work on stuff that's like very esoteric, and so I don't know how much progress I could make using. I use Copilot a little bit, but I don't know.
Well, Mike, you bring up a really excellent point in that prompt engineering does actually matter. So instead of saying, write me a function to do X, if you can give it a lot more information about exactly what you want, then it can do a better job of helping you. I don't actually have any examples written down for this talk, but I will try to have some by next January or February or so.
I find one of the best languages I've seen it suggest is actually this one called Lean. It's like a proof checking thing out from Microsoft Research. My hypothesis is that there's so much, there's a vast sea of bad JavaScript, bad C++, bad Python. The only people writing Lean are like uber math nerds, and everything is like perfect online. And if it doesn't compile, it like won't work. And if it compiles, it'll probably work. So it just is learned from like perfection versus, there's a lot of like really bad C++, and you can see when it suggests these things. So
Hey, you make an excellent point, and these models have been trained on all C++, not just good C++.
Yeah.
it doesn't really know the difference, unfortunately.
Yeah, it doesn't know. I'll jump in on that from another direction. This was many years ago. It was prior to the whole LLM thing. So we're just thinking deep neural nets, right? I did all of these models of deep neural nets, LLMs, everything. They are hugely sensitive to the data set you train on,
Yes.
especially when you move into gaps that they haven't been explicitly trained on, right? When they start in
Interpolate, yeah.
So I won't say who or what or so forth, but we were doing a project where it was essentially for a toy, and it was going to have a model for embedded voice recognition, but for children, right? So most of the voice recognition models are, especially at that time, were built for adults. Children have a very, very different spectral characteristic to their voice. And so we basically took all of them available at the time and ran identical samples of children's voices through them. It was very obvious how they were trained. Certain models, here, certain models, without saying who, every time it didn't get something it recognized, it just spontaneously, and these were speech to text, right? So that we were looking at the text. It just spontaneously output the product of the manufacturer. It was that type of stuff. One of them, I don't know what they trained it on, but it was just an absolute pervert. I mean, the conclusion that went back to in the report was, this model is not suitable for children, full stop. Right.
I did a voice recognition thing using Google API for a chess program. Most of the time it recognizes porn when you say pawn.
Yeah.
So it's obvious
exactly that type of stuff.
It's obvious what it was trained on.
Yeah, exactly. So it was really hysterical on one hand, but it was really telling about, well, all these things are awesome, so I'm not dissing them in any way. It was really obvious what, some of their weaknesses are, right? They are a statistical model that doesn't really understand, at least yet, what it's doing. And that's its biggest, hiccup. Okay.
Yeah, so I had this other idea, right? So languages like Lean are very strongly typed, right? And if you could somehow combine like the LLVM producing a code in a language like that, and automatically checking whether it's right, and then automatically making suggestions or changing the prompt, right, based on the error messages or something. So it's kind of like, you kind of like take the human out of the equation, right? Like that you actually have like maybe even like a separate AI that's editing the prompt for you to make the other AI work better, right?
But proving
That's
that
cool
something,
research there.
proving that something is correct needs a specification of what is correct. And without that, there's no machine nothing that can prove a piece of code does what? Something.
Right.
Who's going to provide the specification? A human
Well,
being.
it's like, yeah, so like if you write the proper types in Lean, you could have that specification, right? But then it's kind of like you've moved up a level you moved up to a higher level language, which is the type. you know,
We did have a talk here. It was probably on the order of 5 years ago, where they had a formal language that was designed for specifications, and they were attempting to compile it.
Mm.
Yeah, if you're interested in that, go back through our records and you'll be able to find something on that one.
Microsoft Research had a static analyzer for driver code many years ago. I believe it's still being used, but that also needed user annotations of correct.
Oh, the safe language annotates the things with underscore that tells you,
Yeah,
here's a buffer of this size.
something like that. I
Yeah.
don't know the
Yeah.
details, but it's a product from Microsoft Research, which is part of the Windows SDK.
Mhm.
Driver developers, it's called static driver analyzer or something. About Sriram developed at Microsoft Research.
so yeah, that's an interesting question. It's like, what if you have the AI write the prompts for you, right? So I've seen it. People have ChatGPT write prompts for like the image generation software. So instead of writing the saying, oh, I want a scene of a astronaut on a horse or whatever, you ask ChatGPT, hey, write me a prompt for the whatever it's called. I can't remember the name right now, Dolly or whatever, and that has a picture, and then so it writes a big long prompt with a story, right? It says, this should look like a movie, blah 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 blah, and people finding that makes better pictures. So maybe you could do that 2-level way of writing software too.
Yes, absolutely.
One possible way you could do what you suggested was that build a separate large language model, which was trained on pairs of code and specifications. Here's a code, here's a specification for which is correct. Feed a lot of that stuff into the model and then ask it, give it a piece of code, say your first Copilot or something generates a bit of code, feed it to the other LLM and ask it, what do you think the specification could be? And a human being could look at the spec and fix it and feed it back to something else which took a spec and generated code. One possible way.
Yeah, there's an AI structure that does things like that called a general adversarial network, where they basically bounce back and forth. One synthesizes, one judges,
Okay.
and they do things like
One,
that.
check,
Yeah,
one generates, the other checks, verifies something.
Yeah, the one you usually see is, trying to make a fake picture, right? So and one's trying to fool the other, right? So one's generating a fake image, and then the other one says, this is real or it's fake, and they do this escalation. Okay, so I think we do have one more presentation for tonight. So let's switch over, and then once that's done, we'll go back to open chat.
Honestly. When you do the thing for next year, would you mind including how to set up the local model?
That's a whole thing.
I think it's the
Is how to attach it to the editor and how to set up the local model. And maybe I will learn some new insights. The conclusions will change.
Should be.
There we go.
All right. Evening, my name is Christian. Been doing C++ for nearly 30 years, and this sounds like the introduction to a therapy group.
Hooray. Hi, Christian.
And by C++ duck typing rules, if that's how it sounds like, that's what it is.
That's what it is, yep.
So I wanted to share with you this therapy group, my impression of doing a first project in Rust. That's more than just a hello world. And it's not a Rust talk, it's just impression and commentary, what So the excuse here is that the excuse for the project is that Unix commands, even with Splunk and all kinds of sophisticated UIs, it's still sometimes the short way to get something done. Pick at a config file, look at how much space I have available of disk, what processes are running, that sort of stuff. And more often than not, I figured that, midway typing the command, I'm actually in Windows. And sure, I can go and install Cygwin. Typically, by the time I install it, I forget what I wanted to do to begin with. Luckily, there's WSL, Windows System for Linux, version 2, which runs like a VM.
Yep.
And that is a pretty good solution most of the time, except when you get confused because what WSL thinks user home is different than where Windows thinks it is. The file system is slower, so if you need to copy large files around, you have to wait, and it runs in its own VM. So for example, if you want to do something like a PS command, it would show you what runs in the VM, not what runs in the native environment. Maybe there is a way, but so I thought it's a good excuse to write my own interpreter shell and to do it in Rust, to learn Rust, and to have it, to have all of the commandlets that I use most often be built in. That way I get full control of the code. I can do whatever they want. It will work the same way across Linux, Mac, Windows. It's on GitHub. And I think the whole experience was under 2 months with heavy help from ChatGPT and from all of my previous experience with C++. So I didn't get a culture shock with running into there's no inheritance and you have to do everything as a trait. That's pretty natural after you've done templates for a while. The things that aggravated me in the first or 2 weeks into the project was, hey, why can't I just send a reference counted pointer from here to there, right? I pretty promise I won't touch it. I won't modify it. So part of this, the shell is an expression interpreter. So it builds a small ASD expressions, right? So I need pointers and so yeah, that's the comment there. It's reference counted like shared pointer except for the shared part. So you have to learn how to cheat about immutability using refcell. And the other comment is that the way I felt about it is that I want to get a thing to compile. So sure, I'm going to say .clone. And it's not always the most efficient way, right? I have a variable table and they're represented as strings. And once you start doing cloning and passing strings around, it's safe, but it's a recipe to generate code that is not performant. Sure, small, tiny interpreter. How many variables do you have? It's not that critical, but something to be mindful of, right? And I was sharing this with a friend, and he said, "Yeah, you go into the weeds," and I almost said, "You go into the weeds with a cow." But yeah, the copy on write is something, or clone on write was something that you have to understand how to use if you want to pass references around rather than strings. That was an interesting experience. Now, going back to WSL for a second, while I was doing this, I learned that if you create a symbolic link from the Linux environment out of WSL, it shows when you do a command exe-dir, or it shows in File Explorer, but if you click on it, you get an error. It doesn't traverse it, it doesn't open it. And it's not seen by the standard library in Rust either. And I took this as a personal challenge. I wanted to get it done in my environment. And after a little bit of research, I discovered that the WSL symbolic links, most of them, there are some that are opaque, but most of them are implemented at the NTFS level as a reparse point, which is a very interesting feature because that's apparently how you can implement links and paths that point to Azure or point somewhere in the cloud, and you can make it look like it's part of the file system, and they're reparsed data points. But not everything seems to be as well documented. So I had to dig in a little bit. And then, let's see, what is this? Keyboard.
And in case you didn't mention it, WSL stands for Windows Subsystem.
Windows Subsystem for
for
Linux.
Linux.
Yeah. Okay, this is a screenshot. Shows how from my environment I do a list and I see the link there. I also give a hint that's created under the WSL. And it works. I can traverse. It works in the. I can show live if there's time.
It's your LS, it's not the WSL.
Yeah, it's my implementation of LS. I cloned pretty much.
What is Windows Crate?
The Windows crate is, so in Rust, libraries are called crates.
Oh,
And Windows crate is an effort from Microsoft to wrap around Windows APIs. So that there is one that's called the Windows API that's part of the standard library of Rust. But there are efforts done here at Microsoft to wrap those around, okay, and to encourage people to. So this is a snippet of Rust that uses a device IO control call into Windows to go and grab that data structure that is the reparse data point, so I can figure out where the link goes. So writing this made me feel a little bit like, it's, you know, there's a cast, you pass a buffer and it's mutable, and it doesn't feel as safe as Rust promises to be. Okay, but it gets the job done. I still don't understand. Something's.
That's weird. It did that to mine.
I was able to switch pages, but so the impression so far, I'm not exactly sure, and that thing I showed on the last page is just an illustration. There are some other features that I had to implement going down into Windows calls, and they all have to be in unsafe blocks. Okay. So the way I felt about it is like many years ago, when ATL Active Templates Library came out, which was let's wrap things in C++ to make COM, to make it easier for people not to forget reference counting and COM and all of that stuff. It feels similar, like, yes, okay, it makes the job easier, but it's not, you still have to be careful not to leak memory or not to pass buffers that are too small, too short, that sort of stuff. So I'm not 100% sold on the promises on safety when you have to integrate with legacy APIs, which is most of the world we live in. The surprise was to me that memory mapped files are considered unsafe. So one of the utilities I built is the file viewer, the less, where you want to scroll through a file. If that file is millions of lines of code, you don't load it in memory map it. And surprisingly, that feature is supported, but it's considered unsafe in Rust. Surprising that with people that do AI training, that's my understanding that how large data sets are memory mapped. So.
considered unsafe, meaning what bad thing will happen?
I don't know. It's just, I'm a beginner. I'm sharing. It's one of my experience. I'm sharing the experience. This came as a surprise. Another interesting thing is, okay, there's no exceptions in Rust. Therefore, if allocations fail, it panics. And it's fine. We've got memory. But what happens if the user specifies a very large number? I want to do a tail on this command, and I want to see the last 10 billion lines, right? So the implementation says, okay, I'm going to reserve a buffer because I'm going to run through it, and this is my running window, and it crashes, right? So it's an interesting change of paradigm where you have to think ahead of time. How am I going to handle a situation when somebody bad input or even ill-intended behavior, somebody wants to give me a super big number, and crash me. In C++, it's all I'm going to handle that alloc, and it's different here. One thing I got to love is the cargo ecosystem, how they handle dependencies. I do not miss building Boost or side C++ libraries.
You might want to explain what cargo is for the Rust beginners here.
So Rust has a tool called Cargo that manages the dependencies, the build, running tests. I don't know how to define it. It seems to be the Swiss Army knife that does everything. It generates documentation. It runs your unit tests. It checks your dependencies. It does like what pip install plus make plus npm.
GTS plus.
Swiss Army knife, you basically cover.
Yeah, it covers.
But it's and you publish your crates to the world through the same system.
Yeah.
And it can be extended. If you write commands called cargo underscore and you place them in your home directory, they will be recognized as subcommands, so you can extend it. Very nice. Also, unit tests, you don't have to go and get a different package, or in a large project. I've seen this happen. 100 people on the project, everybody has their favorite unit test framework, and they're all in the system, okay? The other thing I don't miss, and this is real life, I've done this at my work once or twice, where you have build systems and we build artifacts with one distro, with one compiler. Accidentally, it gets pulled in another build. Things sometimes compile and run, which is scary, and sometimes they crash with very unexpected. You have to look at the stack trace and say, oh, you have a different understanding of what this template instantiation was. Extremely difficult to debug. Looks like, if anybody knows otherwise, that it can still happen with Rust, I'll be interested in learning.
So,
This experience so far, you can.
yeah, if I could jump in on that one for a second. So basically what Rust does under the covers is every package is versioned. And if one package specifies another package, it's versioned. So you can have multiple versions of the same package correctly in the hierarchy in a single Rust program. And that basically eliminates the diamond problem.
It leads to a little bit of code load.
It does.
So
That's
in
the
my
downside.
case, I picked the latest Windows crates to
Mhm.
use. But then I have other dependencies and they use different versions. So it looks like they're all in their namespace, but they're all in the executable. I have not yet figured out what the technique is to do a graph visitation and figure out the minimum common
There is one.
There is cargo 3-D and there are some tools. I
Yeah.
haven't just gotten there.
Yeah, I don't remember what it is, but there is a dependency lister that runs out of cargo and it'll list your
Yes,
dependencies.
but then of course, one of your bill of materials, one of your components changes and then this whole thing goes out the window.
Right.
But, all right. Now, as a bonus, this was a fun thing I ran into when I put the project, when I enabled the continuous integration with GitHub, okay? So I had a test that looks like this: if one true, else false, right? Prints true. And I thought, this is too simple to mock, right? It's what dependency does this thing have? Nothing. Right? I want to test my expression evaluator. I'm going to do this. And it took maybe like half a day to figure out what was going on. And what's going on is that when I build the ASD in the interpreter, I distinguish between string literals and commands, because if you say bogus minus AL, that is a binary subtraction. And it says I cannot subtract two strings, thank you very much. But if it recognizes that ls on the left-hand side is an expression, then its context, it determines from the context that the minus is a flag, okay? And it turns out that true and false existed on the VM in GitHub that when I was running these tests. And I have a thing built into this little interpreter that dumps the ASD. And that's how I finally figured it out, because I had no idea what was going on. And I think the moral of the story goes back to after, right? so many years of experience and you still think some things are too simple to mock. And it's not a database. It's not something where I need to inject my own dependency. I'm just run it as is. And apparently not. So better mock everything. Yeah, this is what I had.
Nice.
All right. And the project is, it will be in the slides, and the crate is published. I'm still fixing bugs related to escaping hex sequences, Unicode sequences, auto-completion. It has a nice feature, which is you can add your own commands to the auto-completion, where it can do things like this. Git shows me that there are 2 auto-completions.
Can you please increase the font?
I think I can, sorry.
Thank you.
Yeah, so I can do. Right. That sort of stuff. So, and this is done with a YAML file that can be put in the home directory the same way the prompt is customized there to look in color. I mean, nothing fancy, nothing innovative, just copying things from how Bash works essentially and replicating it in a smaller scale in Windows. So that's the commands. So that link works in tab expansions as well, right? So it's like this. All right, that's cool. That's my presentation. Thank you.
Very cool. Great work.
And to dovetail into your presentation, Pete, like I said before, a lot of ChatGPT assistance to learn. Also, because a lot of these commandlets follow a similar pattern. Once I had like 5 or 6 done, I would use them to cut and paste and say, using this as a guideline, an example, please write me a command that does blah, and then I would do that and massage it by hand. So very productive. This is let's see, to use the tool to do word count lines. All right, 13,000 lines of code, which I don't think I can crank that many in 6 weeks as a hobby project by myself. So it's a lot of AI system.
So what percentage speed boost do you think you got from using AI? Was it up to a factor 2, more than, less than?
Oh, it's hard. I don't have a baseline, but I would say, yeah, it's hard to measure because I was comparing how many years it took me to learn C++, but obviously I started when you had to go to the library or ask a friend that knew how to do it, right? There was no way to get online, and then writing code, my mileage varied with, I think I measured 1 year, I tracked, and I think I wrote maybe 30,000 lines at work in 1 year. So doing this that was maybe 15 years ago. So if I take that as a baseline, and now we're saying a third of that done in 6 weeks.
In a language you didn't know well.
In a language I didn't know at all. I read the book a weekend, maybe a year ago.
Did you ever, so one of the things that has, I tried Rust a couple years ago. I haven't come back to it, but the one thing that was very tricky compared to how I'm used to doing things in C++ is that like sometimes you'll like get partway down some path of like how you want the architecture to be, and all of a sudden you're like, I don't really like this. Let me try to slowly move this over to this other thing. And in C++, a lot of times you can be like, you know, you can kind of like make these temporary compromises on your way to your final thing where you're like, I promise that reference you have is totally going to live to the end of your lifetime. Just like, don't complain for now. We'll be fine at the end.
I'm okay with this link right now.
Yeah. You're like, I'll like, you know, I'll just use shared pointer. That's not necessary, but just want to do it. But the one thing that was always hard for me in Rust was like, you can't do that because it just like you make one change and it's like, oh no, doesn't your two references that are mutating can point to the same thing. You can't do that anymore. I'm just curious if you ever had that experience where like, oh, I had this better idea to rewrite my code and it was like,
No,
Right. Yes. The answer is yes. I ran into that. And I unstuck myself by using lots of clones
yeah.
and passing things around and then,
Check it into a branch to rethink it the next day, but sometimes it's not worth it.
right. I mean,
yeah.
No, I do a fair amount of Rust. When I'm actually coding and not doing other stuff, but no, when I learned Rust, that was exactly the paradigm. Is Rust makes you think more holistically about things.
Yeah.
Because you got to figure out the dependencies and the borrow checkers and the lifetimes and all that stuff. And yeah, that eventually you kind of get past it and you learn just better ways of doing things to begin with. But there's definitely that learning curve. It's definitely painful.
Yeah.
It's definitely worth going up. And to your point, this is one of the things that drove me insane. Because a lot of the stuff I do is generally high performance type stuff, right? And I was cloning. I just finally got to the point. I'm just going to clone it, right? Because I just need to get past it. This isn't super critical. And the interesting thing that really got me with Rust is even knowing I clone stuff all over the place, which, you know, this group considers bad, my code was actually more performant than the C++ equivalent.
interesting.
And I'm not sure exactly what's happening with the clone, because sometimes Rust can elide and do.
Clone doesn't always mean copy memory, right?
Right.
So when you pass a string around, it will not duplicate. It will pass the
That's right.
inner data structures like the length and the pointer, right? It's like it's a move semantics.
It's a move semantics and it elides and it does that very efficiently.
Yes.
There's actually one thing, and it took me several years to realize this was going on. And I was getting a sense of it, and I finally went to a CPPCon talk that just basically stated it. Because of the borrow checker, you don't, by definition, you basically don't have aliasing, right?
Mhm.
Okay, it just eliminates that. Once you don't have aliasing, the optimizer can go for it.
Yeah.
Because it can make a lot more guarantees. And so, you know, the advice I've given folks when they're kind of learning Rust, because like you, I've got, you know, other people coming in, some younger, but I've trained up a lot of people switching from C to Rust because we use both, right? And I tell them, go copy. It's not going to hurt you.
Well,
and then fix it later if it does.
Again, when you do a clone, it depends on the objects.
That's right.
Right. So if you clone a reference counted, an RC or an ARC, which stands for atomic reference count, right? So it's safe across threads.
Mm-hmm.
It doesn't clone the object under it just dumps the reference count.
Yeah.
That's all that clone does. So it's very cheap.
The other thing that Rust has internally, and I'm not a super deep Rust expert by any standard. I'm learning it myself after a few years. But it has these things called wide pointers, which are essentially, they just tend to call them wide, you know, sometimes wide pointer. I see it in a couple of different contexts. But fundamentally what it is two, we'd call them ints, right? Just natural lengths. But it's two of them just stuck together. And I got a sneaking suspicion it's able to optimize that somehow through the processor. Mm-hmm. It uses them all over the place like a string, right? It's a pointer and a length. When you do an impl, it's a V table under the covers. And what you end up passing is this wide thing, which is a pointer to the V table and the length. And they tend to use that, from what I've seen, a lot. And I don't know for a fact, but I've got a sneaking suspicion there's some optimization around that, in addition to just what you're saying of, you don't have to really do the thing, right?
So one thing I forgot to put in the slide is that, well, I'll show it here in this example. So one thing I did was to mock the sudo command, right? So you have sudo in Linux, that means substitute user and do, and the user is root if you don't say what it is. But Windows doesn't have the same semantics. So if you run as, there's two run as. There's the program run as. If you run as administrator, it doesn't elevate. So here I implemented it by doing actually UAC elevation, right? So it does this, right? So it starts another window and it does this. But one of the features I have here is I can pipe things, right? So I can see a list of system running processes, and I can take, like I was saying, just the head of them, right? So I implemented pipes. But you cannot do this because the elevated in Windows, your elevated thing runs in a different desktop. So what I do is I catch this and I say, no, sorry. You just can't do that now. But now what happens if I'm doing the cat command with no file, which means read from the input until the user is right? It does this, I get an error, but I am stuck here, and luckily
So I have to do Control Z, okay? So I experimented with the following.
So Rust, by default, all of the reads are blocking reads. There is this thing called the Tokyo runtime, which is an infrastructure for doing futures and for doing async await type of stuff. So I thought, well, okay, what if I use Tokyo to do my reads on the left-hand side asynchronously? If the thing on the right-hand side fails, then I'm just going to raise a signal of sorts and say abort. It didn't work quite right because I was left with schmutz in the pipes. And then the next time you do a command, it either doesn't read because there's still something stuck, or something will come in the output. So I decided to just, okay, I'm going to put a message there, say press Control Z to output to end the input, and
you're bold. I've been doing Rust for not many years, but several years, and I still haven't gotten into the async stuff.
It's actually quite neat, and I like it.
Okay.
Well,
async stuff is not new. It goes back to doing select or wait for multiple objects, right?
Yeah.
But then you get language constructs that make it.
But yeah, the language constructs are very obtuse.
You don't have to do callbacks and keep mental track of that. But essentially is, I'm monitoring a bunch of handles.
Yes.
And as soon as something happens, and then there's like smart scheduling, because you can run something on a thread and move it towards making. I probably spent like a few days exploring that, 2 or 3 days, and then I was like, okay, for some other, it's advanced. All right.
Okay, cool. Thank you. We've got about 12 minutes left if folks want to keep talking, or might be some pizza left, or wander out and give our host a little bit of a reprieve on getting out of here on time tonight.
So, interesting algorithmic problem, which is to do the process tree to the PS and show things as a tree. Whoops. Could be right. Do this without your lines overlapping and sorted nicely. By the way, under Windows, you would think that this doesn't have loops. It does.
Oh yeah.
Okay, so I have to deal with that. And another fun algorithmic thing was implementing the which is one of those things. If you ask ChatGPT how to do it, it will not do the most efficient thing. This thing has, and it produces patch files compatible with the patch command in Linux, and it's slightly over 300 lines of code, including all of the boilerplate, right? So you can do you can do performance things, playing a little bit with the lifetime specifiers there, because the view should be lightweight. But the part that actually computes the diff itself is this. It's a breadth first search that puts things into a grid, and then it finds the shortest path in a graph from file A to file B. And then the printing just walks it back. So it's a nice language to do algorithmic things in and do it performantly. So.
Cool.
All right.
Well, thanks, folks. Sounds like we're kind of winding down. So thanks, folks online. We'll be back next month with a regular presentation. I got to get hold of the speaker yet, so we're a little hedge there, but we should be back to normal, our normal format next month. Yeah. Thanks, everyone.
In 6 weeks, that's pretty impressive.